Hello everyone, welcome back to Holi-Tech Academy. So in this particular third part, we'll be discussing the derivation of electric field intensity due to a circular coil, and we'll also solve a problem on tension caused by a charge on a wire connected to a simple pendulum. Let us derive the expression for electric field intensity due to a circular coil. Let us consider capital Q, that is the source charge, which is uniformly distributed along the circumference of a coil, which is having the linear density of lambda. No, lambda is linear charge density. Now let us consider point P somewhere outside the circle, and now we have to calculate at this particular point how much is the total electric field intensity due to the presence of this circular coil. Now let us consider an elemental strip AB. Okay, this is an elemental strip AB. The charge distributed here is dq, electric field intensity is dE, and its length, that is per unit length, is dl. We know the expression for calculating the linear charge density, that is lambda is equal to dq upon dl. So can we write dq is equal to lambda into dl? The differential charge on AB, that is dq on AB, is equal to lambda into dl. We know that electric field intensity on AB, the expression for that is K into dq upon r square. Write the distance from the center of the circular coil to the point B, B, x. The distance from the elemental strip AB to the point P is r. The radius of this circle is capital R. By Pythagoras theorem, we know this small r is equal to under root of r square plus x square. This is our equation 1 and this is our equation 2. Now substitute equation 1 in 2. We know that dE is equal to k into dq is what? Lambda into dl, and r square is what? R square is nothing but root of r square plus x square whole square. Now square and this root gets cancelled, so it is k into lambda dl upon r square plus x square. Now the electric field intensity from the elemental strip AB to the point P is dE, which is making an angle of theta with respect to horizontal. So if we resolve this component dE, it becomes dE cos theta in the horizontal direction and dE sin theta in the vertical downward direction. And if we consider one more elemental strip somewhere here downside, here also what happens? The distance from this particular point to the point P, here again the electric field intensity, if we take it as dE, because dE is common everywhere, and if this is the angle theta making with respect to the horizontal, again this can be resolved into dE cos theta, and on the horizontal upward direction it is dE sin theta. That since the magnitude of these two are same and they are equal and opposite, they get cancelled out. Yes or no? So what gets added up? These two components get added up in the horizontal direction. Here we are considering one elemental strip and here we are considering the other elemental strip. And there are n number of elemental strips. That's why we have to integrate that. And the integration of net electric field is in the horizontal direction. Okay. We have to integrate d cos theta because there are n number of such electric field intensity lines. So integration of 0 to what is the circumference of the circle? It is 2 pi r. Circumference of the circular pi is 2 pi r of dE into cos theta. Okay. Now what is dE here? We have seen the expression for dE here, that is k into lambda dl upon r square plus r square. Let us write it that integration of 0 to 2 pi r k into lambda into dl upon r square plus r square into. Now let us understand what is cos theta here. So let's draw this triangle that is shown here. This triangle, let us draw it. So if this is theta, this will also be theta, right? And this is the radius of the circle, and this is the distance from the center to this point P. And this is the top. And this hypotenuse, we know it is r square plus x square. So what is cos theta here? Cos theta is nothing but adjacent divided by hypotenuse, x divided by root of r square plus x square. So let us write this value here, x into under root of r square plus x square. So this is equal to, now we have to differentiate dl and other things are constant. Let's bring it out. K into lambda into x divided by r square plus x square. Okay. So this is power is 1 and here the power is 1 by 2. So 1 plus 1 by 2 is 3 by 2. Integration of 0 to 2 pi r dl. Okay. So the integration of L is dl is L to the limits 0 to 2 pi r. So k lambda x divided by r square plus x square to the power 3 by 2, 2 pi r minus 0. We have applied the limits. So this will be k lambda x into 2 pi r divided by r square plus x square. We have the expression for linear charge density as q divided by circumference. So q divided by 2 pi r is equal to lambda. Q is equal to lambda into 2 pi r. Okay. Have lambda. Also we have 2 pi r. Can we replace lambda of 2 pi r to q? So it will be k into q into x divided by r square plus x square to the power 3 by 2 or electric field intensity due to a circular coil. Pendulum bob. So it is a pendulum, simple pendulum. It has a bob. It is carrying a charge of 2 into 10 raised to the power of minus 8 coulombs. And it is carrying a mass of 80 milligrams. Mass is equal to 80, which is 80 into 10 raised to the power of minus 6 kg. Okay. And it has a uniform electric field of 2 into 10 raised to the power of 4 volts. E is equal to 2 into 10 raised to the power of 4 volts per meter. Find the tension in the thread of the pendulum and angle it makes with the vertical. As the simple pendulum swings and later the tension is created in the upward direction. The tension is created. Okay. You all know that the tension is created on the upward direction, right? So tension is created here and again here also the tension is created in the upward direction. And this is making an angle of theta with respect to this position. So if we draw a vertical component, it is also making an angle of 30 theta itself. It is also making an angle of theta itself. So it is resolved into vertical component as t cos theta and horizontal component as t sin theta. We also know that it experiences an electrostatic force that is equal to charge times multiple of electric field intensity. Okay. And its weight is acting in the downward direction, that is mass into acceleration due to gravity. Okay. They have asked us to calculate the value of theta and they have asked us to calculate the tension. Okay. So the horizontal components, these two, they are equal and in opposite direction. So I'll equate it. T sin theta, T sin theta is equal to QE. And the vertical components, these two, they are equal and opposite. So T cos theta is equal to mg. So this is my equation 1 and this is my equation 2. Divide equation divided by equation 2. So T sin theta divided by T cos theta is equal to QE divided by mg. So T gets cancelled. Sin theta by cos theta is equal to tan theta. Tan theta is equal to Q. What is the value of Q over here? Q is 2 into 10 raised to the power of minus 8. 2 into 10 raised to the power of minus 8. The value of electric field intensity is how much? 2 into the 10 raised to the power of 4 volt per meter. 2 into 10 raised to the power of 4 volts per meter. And we have mass as how much? Mass is 80 into 10 raised to the power of minus 6 kgs. And acceleration due to gravity is 9.8 meter per second square. So if you calculate this, this will be somewhere equal to 0.51 is equal to tan theta. Theta is equal to tan inverse of 0.51, which is equal to 27 degrees. Hence, the tension component again we have to find out T. Now we have to calculate T. We know that from equation 1, T sin theta is equal to QE. T sine of 27 degree is equal to, what is Q here? Q is 2 into 10 raised to the power of minus 8 into electric field intensity is how much? 2 into 10 raised to the power of 4. Okay. So T, if you calculate this, you will get it as 1.727 into 10 raised to the power of minus 4 Newton.